Hi, my name's Cora. I'm a structural engineer here at IBHS. We're standing in front of our test specimen here in our test chamber. This project is called damage amplifiers, where we're studying the cascade of failures that occur when small features of buildings are damaged. So in this project, we've been testing multiple overhang structures, so different porches and patios attached to different sides of the building, but also different wind angles as well. The column bases are often in very poor condition, or they've just not been secured correctly. When these fail, which often happens as we've seen in damage surveys, this can result in that porch or patio being lifted up or flipping over and then creating a lot of damage on the main roof structure of the building. And that's why we call these features, these overhang structures, damage amplifiers. Each of these have failed in different ways, have caused different amounts of damage to the building. In this case, this has created the most substantial damage to our structure. The column bases of this patio cover failed. It then flipped back and collided with the rake edge of this house. That set off this cascade of failure, especially where the bridge line to rafter connections failed and a large section of the roof was removed.
That would be this one is missing, right? Here?
So this morning we're actually doing a damage survey. So the way we do this is very similar to how we would do this out in a field after a hurricane or a thunderstorm.
Versus it would just have pulled out and it would have stayed in the roof, right? Because now you're gonna break the sensor here.
Mm-hmm. Right.
Over here we'll be getting up to the roof level and examining all those failed connections and trying to understand that sequence of failure and what the weak links were in this building. We'll also be going outside the chamber and looking at the debris field and how that debris has been strewn across the field outside.
Ceiling joist, right? It's a ceiling joist, yeah.
This can give us clues as to not just what has broken, but what has stayed together and can help us understand the structural performance in these very extreme wind events. The main reason why we test at full scale here at IBHS is to be able to understand the cascade and the progression of damage within a structure. These are things that we just can't scale down. And so that's why we actually build real houses and real buildings in real wind and to try and understand the sequence of failure and how a house tears apart in a hurricane or a thunderstorm.